say scientists. Tidal action on the underside of the Thwaites Glacier in the Antarctic will inexorably accelerate melting this century, according to new research by British and American scientists. The researchers warn the faster melting could destabilize the entire West Antarctic ice sheet, leading to its eventual collapse. The massive glacier, which is roughly the size of Florida, is of particular interest to scientists because of the rapid speed at which it is changing and the impact its loss would have on sea levels, the reason for its Doomsday moniker. It also acts as an anchor holding back the West Antarctic ice sheet. More than 2 kilometers, 1.2 miles, thick in places, Thwaites has been likened to a cork in a bottle. Were it to collapse, sea levels would rise by 65 centimeters, 26 inches. That's already a significant amount, given oceans are currently rising 4.6 millimeters a year. But if it led to the eventual loss of the entire ice sheet, sea levels would rise 3.3 meters. While some computer models suggest reductions in greenhouse gas emissions under the 2015 Paris Agreement may mitigate the glacier's retreat, the outlook for the glacier remains grim, according to a report by the International Thwaites Glacier Collaboration, or ITGC, a project that includes researchers from the British Antarctic Survey, the US National Science Foundation and the UK's Natural Environment Research Council. Thwaites has been retreating for more than 80 years, but that process has accelerated in the past 30, Rob Larter, a marine geophysicist who contributed to the research, said in a news release. Our findings indicate it is set to retreat further and faster. Other dynamics that aren't currently incorporated into large-scale models could speed up its demise, the new research shows. Using a torpedo-shaped robot, scientists determined that the underside of Thwaites is insulated by a thin layer of cold water. However, in areas where the parts of the glacier lift off the seabed and the ice begins to float, tidal action is pumping warmer sea water, at high pressure, as far as 10 kilometers, 6 miles, under the ice. The process is disrupting that insulating layer and will likely significantly speed up how fast the grounding zone, the area where the glacier sits on the seabed, retreats. A similar process has been observed on glacier in Greenland. The group also flagged a worst-case scenario in which 100-meter or higher ice cliffs at the front of Thwaites are formed and then rapidly carve off icebergs, causing runaway glacial retreat that could raise sea levels by tens of centimeters in this century. However, the researchers said it's too early to know if such scenarios are likely. A key unanswered question is whether the loss of Thwaites Glacier is already irreversible. Heavy snowfalls, for example, regularly occur in the Antarctic and help replenish ice loss, Michelle McLennan, a climate scientist with the University of Colorado at Boulder, explained during a news briefing. The problem though is that we have this imbalance. There is more ice loss occurring than snowfall can compensate for, she said. Increased moisture in the planet's atmosphere, caused by global warming evaporating ocean waters, could result in more Antarctic snow, at least for a while. At a certain point, though, that's expected to switch over to rain and surface melting on the ice, creating a situation where the glacier is melting from above and below. How fast that happens depends in part on nations' progress to slow climate change. Introduction. The Thwaites Glacier, often referred to as the Doomsday Glacier, is located in West Antarctica and has gained significant attention from scientists and environmentalists alike. Its massive size and potential to contribute to rising sea levels make it a critical focus of climate research. As global temperatures continue to rise, understanding the dynamics of the Thwaites Glacier is more important than ever. Thwaites Glacier spans approximately 120 kilometers, about 75 miles, in width and is about 4 kilometers, 2.5 miles, thick in some areas. It feeds into the Amundsen Sea and plays a crucial role in the stability of the West Antarctic ice sheet. The glacier's grounding line, the point where it meets the ocean, is retreating at an alarming rate, influenced by warming ocean waters. Preventing the Doomsday Glacier, strategies for mitigation. The Thwaites Glacier, often dubbed the Doomsday Glacier, poses a significant risk to global sea levels as it continues to melt due to climate change. As scientists strive to understand its dynamics, it is crucial to explore effective strategies for mitigating its impact. This article examines various approaches to prevent further destabilization of the Thwaites Glacier and address the broader challenges of climate change. Climate change and global warming. The primary driver of Thwaites Glacier's melting is climate change, particularly rising global temperatures. Increased atmospheric CO2 and other greenhouse gases contribute to warming oceans, which erode the glacier from below. To address this, comprehensive climate action is necessary. Ocean dynamics. Warmer ocean currents reaching the glacier's grounding line exacerbate melting. Understanding these oceanic processes is essential for developing targeted intervention strategies. Mitigation strategies. Reducing greenhouse gas emissions. One of the most effective ways to mitigate the effects of climate change is to significantly reduce greenhouse gas emissions. This can be achieved through transitioning to renewable energy. Shifting from fossil fuels to renewable energy sources such as wind, solar, and hydroelectric power can drastically cut emissions. Energy efficiency improvements. Enhancing energy efficiency in buildings, transportation, and industry reduces overall energy consumption and emissions. Carbon capture technologies. Investing in technologies that capture and store carbon emissions can help offset the impacts of existing emissions. Climate policy and international cooperation. Global cooperation is vital for addressing climate change. Key strategies include international agreements, strengthening agreements like the Paris Accord to ensure that nations commit to emission reduction targets. Funding for climate research, increasing funding for research focused on glacial dynamics and climate science to enhance our understanding and response strategies. Support for developing countries, providing financial and technical support to developing nations to help them transition to sustainable practices and adapt to climate impacts. Innovative approaches to glacier stabilization. Geoengineering solutions. While still largely theoretical and controversial, geoengineering could play a role in mitigating the effects of climate change. Potential strategies include solar radiation management. SRM techniques that reflect sunlight away from Earth could help lower global temperatures. However, the risks and ethical implications require thorough examination. Ocean fertilization. This involves adding nutrients to the ocean to promote phytoplankton growth, which can absorb CO2. However, the ecological impacts must be carefully considered. Ice shelf reinforcement. Research is ongoing into the feasibility of reinforcing ice shelves that support glacier like Thwaites. Approaches could include artificial ice shelves, creating structures that mimic natural ice shelves to slow melting processes. Seawater injection, investigating the possibility of injecting cold seawater to stabilize melting regions of the glacier. Community engagement and education. Raising awareness. Public understanding of climate change and its effects on glacier is crucial. Strategies include educational campaigns, implementing programs to educate communities about the importance of glacier and the impacts of climate change. Citizen science initiatives, engaging the public in data collection and monitoring efforts can increase awareness and promote community involvement in climate action. Advocacy and policy change. Encouraging citizens to advocate for sustainable policies at local, national, and international levels is essential. This can include supporting environmental organizations. Collaborating with organizations dedicated to climate action can amplify efforts to protect vulnerable ecosystems. Participating in policy discussions. Encouraging public participation in climate policy discussions ensures that diverse voices contribute to decision-making processes. Conclusion. Preventing the destabilization of the Thwaites Glacier requires a multifaceted approach that combines emission reductions, innovative solutions, community engagement, and international cooperation. As the consequences of inaction become increasingly dire, it is imperative that we act decisively to protect this vital component of our planet's climate system. Addressing the challenges posed by the Doomsday Glacier is not only crucial for preventing sea level rise but also for safeguarding our future on Earth. Mechanisms of melting. The glacier is primarily losing mass through two mechanisms: surface melting and ice melt from below. Warmer ocean water circulates beneath the glacier, eroding the ice from below and contributing to its instability. As the glacier melts, it not only adds fresh water to the ocean but also destabilizes neighboring ice structures. Potential impacts on sea levels. Contribution to rising sea levels. Research suggests that if the Thwaites Glacier were to collapse entirely, it could lead to a global sea level rise of over 3 meters, about 10 feet. This would have catastrophic implications for coastal communities worldwide, leading to displacement of millions and significant economic challenges. Tipping points. Scientists warn that Thwaites is at a tipping point. Its melting could trigger a chain reaction that destabilizes other glaciers in the region, amplifying sea level rise even further. The potential for rapid, irreversible change highlights the urgency of monitoring this glacier closely. Current research and monitoring efforts. International collaborative studies. Numerous international research initiatives, such as the International Thwaites Glacier Collaboration (ITGC), aim to study the glacier's dynamics. These teams employ advanced technologies, including satellite imagery and underwater drones, to collect data on ice thickness, melt rates, and ocean temperatures. Recent findings. Recent studies have revealed that the glacier's grounding line is retreating faster than previously thought, and its ice shelf is thinning. The melting rate has tripled over the past few decades, emphasizing the urgent need for continued research and data collection. Future considerations. Climate change mitigation. The Doomsday Glacier serves as a stark reminder of the impact of climate change. Mitigating its effects requires global cooperation to reduce greenhouse gas emissions and implement sustainable practices. Protecting this crucial area is essential for understanding broader climate patterns. Public awareness and policy implications. Raising public awareness about the implications of Thwaites Glacier is crucial. Policymakers must prioritize climate action and invest in research to better prepare for the potential impacts of sea level rise. Education and advocacy can help drive meaningful change. Conclusion. The Thwaites Glacier is not just an isolated ice mass, it is a vital indicator of the health of our planet. As we continue to study its complexities, we are reminded of the interconnectedness of climate systems and the urgent need to address climate change. Understanding and monitoring the Doomsday Glacier is essential for predicting future scenarios and protecting vulnerable coastal populations worldwide.